I have a cluster running and I have a Gloo Enterprise installed. So you can see that I have all the pods are running. So the developer portal is an enterprise only feature. And it consists, I have the developer portal installed here as well. It consists of two pods. So one, the dev portal pod is just the controller that processes the resources that make up, that configure the developer portal and also implements the web server that serves the portal applications. The admin server is what backs the admin UI. And as you can see here, like for this like simple demo, I just port forwarded the admin server pod. And this is what the landing page of the UI looks like. Now, I want to start by showing how the new API allows greater flexibility and new features for you when you want to expose your APIs. So the starting point for an API is an API doc. And an API doc is a concept you might be familiar with if you use the first version of the developer portal. It's just an open API specification that describes your service. Now I have some files here that I can ready to use. So I also want to mention that I have a simple service deployed to my default namespace. So it's the pet store service that we use for a lot of demos. And here I'm going to upload the open API specification that describes that service. So I can upload it into the UI and basically start building the catalog of all the services that you have running in your backend. And you can see that the system was able to parse the open API specification, derive information from it. So you can see the different operations, the paths, and the methods associated with these operations. Now, an API doc is a description of the structure of a service. What is missing from an open API doc and a piece of information you might want to provide separately is where does the service live? Where do you want to route the traffic to? And you could have the same definition of an API doc. You could have an API definition, but you want to send the traffic to a service in the development environment in one case, but you want to send the same traffic to a production service in your production environment. So you have this one-to-many relationship between backends and API definitions. So a missing piece, the second piece that we need to actually generate the configuration and complete the API definition is what we call a route. So a route is really just a routing destination for traffic. So here you can see that I'm going to add a simple route to my pet store service. You could do traffic splits, you can do header manipulations. There are different advanced configurations, but for our use case, we just want to send basically to represent our Kubernetes service. So now that I have both of these objects in place, I can create what we call an API product. And an API product is the central object that drives that can be published to portal and that drives the configuration of your Gloo API Gateway. So I'm going to call this API product pet store. I need to fill out the required fields. I need to associate a domain with the API product. This is the domain the users will be able to query it. So I provisioned some DNS records here that map to my Gloo gateway proxy. You can upload an image. We'll see later that this will be shown in the portal UI. And then you can select the operations that you want to expose on your API product. So this is a level of indirection between what your actual APIs are and what you want to expose to your consumers. I have only one API doc here, so I can only choose between the operations on that one API doc. But if I had more than one, I could basically just choose the operations that I want to be exposed in this API product. So let's say that I want to only select read operations. So the two get endpoints, I can select only those. I'm going to create an API product. And Now you can see that all the information that I've inputted is available here. And what I need to do is I need to specify the route that, that is going to apply to this API product. You can specify a default route for the whole object, or you can specify different routes for different operations. In this case, I'm going to keep it simple and just set a default route. Now that I have all objects, you can see that the status is green, and we have our API definition. Now, as I mentioned earlier, we can use this object to actually generate configuration for the Gloo gateway. So you can see that I don't have any virtual services. And if I flip the switch here, this will instruct the developer portal to actually generate a routing configuration for the gateway. So now if I come to this screen, you can see that the developer portal generated a virtual service for my domain with all the operations that I defined in my API product. And so we basically were able to ensure that all the routing rules are in place to route to my service based on my service definition and some simple customization that I can apply to this API product object. Now, this is only one part of what the developer portal does, so generate a configuration for Gloo exposing this high-level API. I want also to show how, like, the new portal features that I mentioned earlier. So to that end, I'm going to create a pet store portal, and I need to provide a domain here as well. This is the domain users will reach, the API will reach to open the portal. I can provide some customizing information, like I can customize the background, I can customize the logo. You might be familiar with this, but I'm going to fill this information out just for whoever is seeing this for the first time. And here I can decide to publish my API to the portal. And I'm just going to click through here. And here we go. So now if we, oops, I need to enable ingress to my router. So similarly, we can generate a virtual service to expose your portal application. So now that I flip the switch, we can see that we have a portal virtual service. And if I go to this address, we should be able to see that the dev portal was able to generate this web application dynamically using all the information that I provided. Now, in the first iteration, of the developer portal, we were only able to set some primary and secondary colors and just the logo and fav icon in the background. So what I mentioned earlier is that now we allow you to provide your own CSS. So let's say that, for example, you want to modify the color of the title of the portal. So what I can do is I can inspect the page to find what CSS class is associated with that element. And by opening this advanced portal customization dialog, I can provide some custom CSS for that element. So for example, let's just say that I want to make the color of the text orange. So if I save this, I come back here, you'll see that the text is now orange. And you can, using this mechanism, you can really modify any element present on the portal. You can provide your own style sheet to change not only the color, but also the spacing and whatever you can control via CSS, which is a lot. So the other new feature I mentioned is the ability to define dynamic pages. So what we had in the first version of the developer portal was the ability to define static content. So I'm going to create a static page here. And this is basically just markdown. So you can define your page and then add some markdown content. Let's keep the typos. And this would generate an additional section in the UI where you can visualize whatever content you defined in the static page, which could be some instructions to get started or whatever other documentation you want to provide. And the new feature that was released with the latest version is the ability to actually define dynamic pages. And as I said, dynamic pages are really applications that we render inside the portal. So to this end, I wrote a very simple HTML file, which consists of just a body and a script that accesses the context of the portal to display the currently logged in user and the API product that the user has access to. So I'm going to upload this file. You can also just provide a URL to the entry point of your application. So it doesn't have to be just a simple HTML file. It can really be, a React app, and you just have to provide the address of the index HTML file that is an entry point to that app. So I'm going to add some information here. Dynamic page, and hopefully, yes, it's available. Now I'm not logged in, so this will show nothing right now because the user is not logged in. But this is just to show that we're able to display that page. And now once we'll be able to log in, I can show you that we can show the information associated with the user and what the user has access to. So this leads me to the next feature that I want to show, which is the OIDC authentication for the portal. So as I mentioned, we can integrate with a server, and we can do that by providing some information. So I'm going to use Google as an identity provider. So I have set up the developer portal as a client for our solo.io application, solo.io organization. So I'm going to use Google as an issuer. I have a client ID here that I registered with Google. I have a client secret that I have provisioned here in the cluster. So you can see that we have a portal OIDC secret. This contains the client secret that the developer portal is going to use to authenticate with the Google OpenID Connect identity provider. So my secret is in the default namespace. The key that stores the data is called client secrets. I need to provide the prefix that will be used by Google to call back to the portal. In this case, it is just the URL of our portal. And I need to tell the system which claim in the ID token that we will receive when a user successfully logs in contains the groups that the user is a member of. That's how we model the permissions, and as I'll show you in a second. So to keep it simple, I'm just going to use the hosted domain name, which is will always be solo.io in my case, and as the element in the ID token, the claim in the ID token that contains the group membership information. Most likely, in a real world use case, you'll have an actual groups claim which consists of a list of groups. So once I have enabled this configuration, I need to actually go and create the second half of what we need to allow OIDC access, which is the name, which is an OIDC group. So we model permissions at the group level in the system, and then we create a mapping between the ID token and the group. So I'm going to call this whatever, solo users. And I need to provide the name of the group as it will appear in the ID token. So on the portal page, we configured which token to inspect for the group membership information. And here we need to specify what the name of the group as it appears in the token will be. So whenever we receive an ID token, which has a hosted domain of which a value of solo.io, we will consider that ID token part of this group. So we give the group access to our API. We don't have any usage plans. I'll show that shortly if I have time. And we're going to give the group access to our portal. And now once everything is in place, we should be ready to go. So if I click on the login button here, I can select to log in with OpenID Connect. And you see I'm redirected to the OpenID Connect provider, so Google in this case. I need to input my credentials. And I'm using two-factor authentication, so I need to use my phone to allow myself to log in. And as you can see, now I am logged into the portal. And if I come back to the dynamic page, oops, wait, let me refresh. Okay, this is, I would have expected this to actually show the information. Okay, I don't know why that didn't refresh immediately, but now you can see that the dynamic page, so the script that I created here, has actually access to the current user and to the APIs that this user has access to. This is just to show how you can use information that are in the portal context in your own application to implement whatever behavior you want. So if I have enough time, I think I might have a minute. I want to show another feature real quick. So I haven't really showed how you can really use the API. So you remember that when you enable the switch here, oops, we created a virtual service. And if I try to curl the domain for an API, you can see that we actually get back a response from our service. So in most cases, you will not want to have your service just publicly exposed, but you want to secure it. So we have this concept that we introduced with the new API of a usage plan. And a usage plan is a set of, it's basically an authentication policy and a rate limit policy. So you can create a usage plan. In this case, we're using API keys as an authentication mechanism, and we're going to define a rate limit of 3 requests per minute for users of this basic plan. You can have multiple access plans on this portal. So now access will be secured. So if I, if I try to query the API again, you'll see that the access is now, I'm getting a 403 error because I'm not logged in. So what can I do as a user to provision credentials for this API? So first, as an administrator, I need to update the group. So, so it has access to the basic plan we just created. And now once I have that permission, I can access the authentication section of my profile, and I can request an API key for the basic plan for the pet store application. So the system is able to automatically generate a configuration so that this API key is valid. And if I now go to my API, which is available here in the API section of my portal, and well, first let's show again that if I try it out, you will get an unauthorized error. And if I use my API key here and send it along with a request, you'll see that now I get a 200. And after 3 requests, 2, 3, on the 4th one, I get a 429 error because I've been rate limited according to the usage plan that is linked to my user. So just to recap, so what I showed here is how you can configure OpenID Connect as a source of identity information for users for the developer portal. I showed how you can customize the look and feel of your portal using custom CSS, implement custom behavior using dynamic pages, and how you can add authentication and rate limit policies to your APIs via the usage plan abstraction. And